This video is about composite functions, and these are functions that are within functions. So we'll have a look at questions like these, and then we'll have a look at questions involving an x. Okay, so firstly, let's look at this. So here's the question, gf bracket 2 close bracket. So what does this actually mean? It means R2 is our input function of the f, firstly, as f is nearest to 2. So let's just quickly. So what this is telling us is that if we start off with our f function and our input value is 2, we replace the x with a 2. So that means the operation over here is 3x, so therefore I would be writing 3 multiplied by 2. As you know that 3x means 3 times by x. Now that results into a 6. So f bracket 2 close bracket is actually equal to 6. So with the 6, you will then use that as the input value for the next function, which is g. And as you can see, g is on the outside, so it's the one furthest away from the 2. So instead of putting a 2, you would actually put 6, as it's an output, into the g function. So wherever you would see an x, you'd substitute that with a 6. So this first part of the expression means 2 times by x, so therefore we have 2 times by 6. 2 times by 6 is 12, add on 5, and then we follow the order of BIDMAS. So the result of gf of x is 17. Let's try another one. So here we go. This time f and g have swapped over position. Now as g is closest to the 2, that means we start off with g. So we put 2 into the g function, and as this means 2 multiplied by x, we're going to times this by 2. So 2 times by 2 is 4, and then 4 plus 5 equals to 9. So our 9 is our output value. Now as 9 is the output value, we're going to place it into the f function. So 9 comes here. So whenever we have the x, we substitute it with the 9. So therefore this means 3 multiplied by 9, which is 27. And that answers this question. And what happens when we don't have numbers appearing inside the bracket? Well, all that means is that the examiner is seeking an expression. So very similarly, if we have fgx, we're going to start off with the g function. And this time, we're just going to replace the x with an x. Well, if you look at that, nothing changes for the expression. So if you replace this x with an x, we'll have 2x plus 5. So that that remains unchanged. But this is now the output value, which becomes the input value for the f function. So instead of inputting an x, you're going to input the output function of the g. So we have 2x plus 5, and we will replace that with wherever we have x in the original function. So that's 2x plus 5, which therefore, as you've written here, it all gets times by 3. So that's just a case of expanding out. So we have 6x, expanding out the 3 and the 5. 3 times by 5 is 15. And that's our overall expression. Well, we can re-practice this skill by doing the same thing in a question like this. So you can either pause the video or just continue to watch. We start off with the f function, and as we're substituting x, this output value remains unchanged. We take the output value, which is 2x minus 2, and then we square it, as the g function tells us to square our x. Well, all you need to remember is your expansion of a double bracket which means if x is being squared, it's the bracket has repeated, and then we start with just expanding it out. 2x times by x is 4x squared, 2x times by minus 2 is minus 4x, and then minus 4x again, and then we have a positive 4 from the negative 2 times by the negative 2. Well, that equals to 4x squared minus 8x plus 4, and that's our answer. So what happens if we swap the positions of f and g? You start off with g of x first. Okay, so gx remains unaltered, and then, what you're putting in for your input value is actually x squared. So wherever you see the x, you're going to swap it with x squared minus 2. And there's no further simplification you can have for that. So you've got that as your expression, so that's your final answer. Now let's try this killer question. Okay, you may want to pause the video and have a go, or just continue and work with me on this one. Okay, so we start off with f of x. So f of x is here. As we're substituting x into the function, this remains unchanged. So what we're really doing is inputting that into this expression. So g, instead of writing an x, you put the output of the f function, and then we're going to expand to x plus 3 to the power of 3. So therefore we have a triple bracket expansion. So we may want to write this out. We have 2x plus 3, then we have 2x plus 3. So this is really what we're trying to do. Now, a quicker way might be, an easier way to look at this, as it does get a little bit complicated, is let's just expand out 2x plus 3 and 2x plus 3. That would give us 4x squared from 2x times by 2x, and then we have 2x times by 3, which is 6x, and then we have another 6x from the second times it multiplies, and then we have a 9. So what we have is 4x squared plus 12x plus 9. Now, as we've expanded these two already, we can just work out what is 2x plus 3 multiplied by the entire 4x squared plus 12x plus 9. Okay, so in this case, it might be easier for you to draw a little box. And perform your triple bracket expansion like this. Let's just amend our box. Okay, so here's how I would do it, just to avoid errors, is write down 4x squared plus 12x with a positive 9 there. We're expanding it against 2x and a positive 3. So all you're going to do is literally multiply these expressions. 4 times by 2 is 8, and then the x multiplying gives us an x cubed. We have 24 x squared. We have our 18x, and then we have our 12x squared, and then we have our 36x, and then we have our 9 times by, which is 27, and then gather your like terms. So the only terms you're going to add are the diagonals. So let's just add up this expression. So we have an 8x cubed. We're going to plus it on to 36x squared, and then these two get added up. And then we're going to add up 36 and a 15, which is 46, and then 50, 54x plus 27, and that concludes our answer. Okay, so hopefully that's made things easier for you.